So any questions? So last time we were talking about proxies, right? And so we talked about different types of proxies, and looked at, synchronized, right? And since it controls access to the underlying structure, right? Sure, only one person, one piece of code can access this underlying structure. But then we get the same sort of structure using Java's unmodifiable list to make it immutable. Then we could chain them, all right? Now, of course, it doesn't make a lot of sense to do it this way because if it's not modifiable, then you don't worry about it being synchronized. But we could chain them, right? So is it a decorator or is it a proxy? So the book says this, right? The same structure. It's all the patterns have the same sort of structure, right? They just put one object inside of another object, right? And they forward requests on. So what's the difference between controlling access to an object and adding responsibility? Is that controlling access or is it adding responsibility? And what's this? Controlling access in what sense?
Preventing change. So right access.
Yeah, it's controlling access to any method that modifies underlying structure, right? But just because we can chain them together, does that make them not proxies? What? You normally don't, right? But think about a web proxy, right? You could have a cache of pages on your local machine, right? And so that's acting like a proxy. So when you go to a web page, you check that cache first. If it's there, then you return it, right? We could then have a campus proxy, which does the same thing. right? Caches come, when a page is accessed frequently, it'll cache them on. And so now before you leave the campus network, right, that request, oh, okay, I haven't solved this. And that's changing, that is basically a chain of proxies, right?
Well, that's why I brought up the example last time of remote proxy.
Right.
To
Right, yeah.
So remote proxy, several
Other proxies,
servers.
right, yeah. And that scenario is probably becoming more common these days, right? You break your server into a bunch of services and you give them different machines. Have people here used mock objects before? What?
I don't know what they are. So.
If you don't know what they are, you probably have not used them. So the issue is, what happens when we have a program that uses data, and now the data is in a database, right? And you want to write unit tests for it. Do you then want your unit test to actually configure the database each time or not? No. So what we're going to do is we can use a mock object to represent the database connection. And we then configure that mock object to react like a database connection. But we configure with certain data, right? So in the first request, you're always going to get the same response. And then we want to create that object so that your program, when it sees it, it says, oh, that is a database connection. That is a fake database connection, but a database connection. And it'll go wherever you can put a database connection. So the mock objects have two important features they need to deal with. One is it has to impersonate the real thing. In Java, that means it has to somehow implement that type, right? So in Java, there is a type which is a database connection, and a mock object has to be able to mimic that and fake the Java type system. And the other is you need to be able to configure it to give certain responses and record the reaction, right? And so it's, when you're writing tests that have external dependencies, mock objects can be useful in testing that. When you have a system, your object dependent upon another part of the system that you don't want to incorporate in your tests, right? We can then, write mock objects for that part of the system, so we're not testing the whole thing, we're just testing a small piece. So when we talk about testing, eventually mock objects sort of creep in, depending on what you're testing. When you're testing things that connect to the network, right? That's tough because that means that how can you know what the response comes back from the network to make sure that we can write the test to make sure the code that does a networking connection works well. If we create a mock network connection, we can then program what that response should be when I make a request. It makes it easier to test that type of code. So here's a sample class. And so here's an example of creating a mock object that represents that. And so what's interesting here is, I give this method mock a class, and as far as Java is concerned, we get something that is of type person. But then what we're saying here is when we call test person age, then we return 43. And now I call test person.age and I get 43. There are a couple of magic things going on here. One is, how does Java have functions? Yeah. So they're faking it with this star, and they make it a static method. Yeah. The second interesting thing is, how does it return something of type person? It has a class, right? But it's returning an object. But the object, Java considers the object of type person. Sure, but then I get a person object, but that's not a person object. Because the person object obviously returns 4 when you call age.
Yeah, that's the real black magic to figure out, is how you get that win. Weird.
So again, what they, it's again a function, right? Where does the function come from? Well, it's actually a static method, right? And they then write it to make it look like English, right? When this happens, then do that.
I get the sentence. I don't get how to implement that. Where is that stored? And then
So yeah, we're definitely not getting a person object. So you think that mock actually creates a well, one suggestion is we're creating a subclass, right? But to do that, we need to compile the class, right? Do what? We just have to call the compiler, right?
It's using weird syntax that class. Just like nothing. There's some trick. I don't even know. Just like pull a subclass out.
You make an anonymous inner class.
That's the only thing that Java is going to consider a person. Anything else, but a subclass or a person. Otherwise, we'll let you text person.
Unless it's built into the virtual machine. No, there is a proxy. There is a proxy object built into the virtual machine, into the language, that can act as a proxy to the real thing. So one way to do that, like you said, is to compile a subclass. Another one is to use a built-in proxy. And I don't know what they do. Yeah, so it's more tell difference, right? What happens if we call age without doing the when? If it's actually creating a subclass. So what we have here is, at least in a conceptually, an example of the proxy, right? Whether or not they actually do the proxy patterns of the story, but it's yeah, a bunch of imports. And so we can actually, do multiple requests, right? Responses. Throw exceptions on certain conditions. Specify responses per argument. And so then we can ask, oh, what does so foo always returns a constant, right? So here I'm creating, one test, cat return this, dog return this, and then when I call rat, I get no. But unfortunately, it doesn't tell us whether it's a subclass or not because it had trapped for these, right? We can check, when things were called. We can actually check the order in which things are called across multiple objects. How many times that are called, right? So if you start writing lots of unit tests, you might find, at least in Java, Mockito, useful. And like I said, you know, conceptually it's an example, another example of proxy, right? Another possible use. So there's all kinds of features. I mean, people have worked on this for a long time. You know, on and on. Oh yeah, SPY is. Now we get what did our class return on name? We return something, right? So if they're subclassing this, they're implementing all the methods and having them default. Now SPY actually gives you right. So we can actually call methods. And so the SPY, you create the real object. And now it's definitely a proxy, right? So just another sort of example of a proxy.
So that syntax will just call verbs out
Right,
in the open, not
right.
assign it to anything inside and out of verbs. That's an interesting syntax.
Yeah, so they're doing several things. One is, to get the function like behavior, you make them static methods, right? So you import them, and then you just return the object you operate on. And so we're just you have to make sure they're chainable, right? And
Yeah, I mean, I kind of get how streams work. They're chainable, but at the end, I'll go somewhere. You
right.
stream as equals blah, 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 blah. Now this looks like it's returning something that just goes nowhere.
Oh, but it's changing the state of, in this case, it's changing the state of SPY properties.
But do returns a stack. You're passing 42. That, and then you're calling a method on that. What object are you calling when on?
Well, so the do return returns an object, right? And you're calling when on that. And then what happens is that when inside that do return object um, stores the 42, right? And will then set, it has to then, right?
So it's an invisible object.
Yeah, doing stuff. And when you think about it a little bit, it's not that difficult to reverse engineer it. The hard part is creating a framework to make it all work properly. I'll take some thought. Yeah, I know. In testing, people have really gone toward this sort of structure where you can make it more readable with the idea that you may want non-programmers to be able to look at your tests and say, yeah, that makes sense. Right. That's something we should be testing. There's also been a lot of movement on domain-specific languages to make languages sort of like this. It's not quite as easy in Java, but it can be done. Other languages make it easier.
I read that Smalltalk compiler code. It's being language one.
Yeah. Yeah. And just another object. So just another example of the proxy, or conceptually, it's quite useful to know about. The bridge pattern. At least the way they say it makes it interesting or it's confusing. It's like you're going to separate the abstraction from how you implement it. And again, we get this almost the same structure, right? We have, this abstraction object has reference to the implementation, and then it forwards the operation into the implementation. And then we have that as a abstract class or interface, and then we have concrete, and so we can change what implementation we want with the abstraction. Which, I mean, how many other patterns do we have that look like that same structure? Right? Well, so the example is Windows, right? So we got widgets, and different types of windows and all kinds of stuff, right? How do we build a framework which we can use like Java across platforms? So one way is, yeah, you create an interface or a window or a button, right? And then you have a implementation for different platforms. So this is what Java AWT did, is it created what's called peers, which were there's a button class for the GUI, and when you finally look down the code, at some point there's a peer, and the peer does the work, right? And so you have to implement a Windows peer and a Linux peer and a Mac OS peer for the button. And then the virtual machine, right? It knows what platform it's on, And so when you say, give me the peer, it's like, oh, okay, I'll give you a Linux button because we're on Linux. Right, and that's what's going on here when you actually in the button, right, there's, go down the code far enough, you'll forward find reference to the peers. Give me the peers. That's this. IBM Smalltalk did this with the collections. And the reason is, for example, sets. How do you want to implement a set? Well, it depends on how big the set is. If the set's small, then just then your list, right? If it's big, then we can use hash table.
So with regular polymorphism, you would just have set on the top and you have linear set.
Right. Yeah.
What's the benefit of that extra level of having an interface and a base class and having them separate?
So in this case, yeah, why not just have linear set and hash set be a subclass of set? And the answer is we can now switch at runtime. So what IBM Smalltalk did is when you create a set, right, if you didn't specify the size, it gave a default size, some small number, and then it was a linear set. But as it grew, then it could actually swap.
So this kind of goes back to what we were talking about earlier about the difficulty of trying to replace an object to change the type of object
right.
at runtime.
Right.
This gives you an directions. Basically change the type of object.
Right. Right. Exactly. Yeah. Plus you never, since linear set and hash set are sort of behind the scenes, we never get stuck by declaring things to be of type linear hash set and then later have to go back and say, oh, sorry, but we want that to be hash set. Can you go change every place that we use that?
Linear set could change hash set.
It could, right. Right. So you just right. And most people probably don't worry about C++, but if you're a Java programmer, you don't understand C++ at all, right? Well, the problem with it. Problem with C++ is when you have a pointer, the programmer is doing memory management, right? Because when you create the memories, the pointer's on the heap, and you have to tell, it's like in C, you have to say you have to allocate the memory, and when you're done with the memory, you have to deallocate it. If you don't deallocate it, it's still there, right? And it can't be used. It's called a memory leak, right? And so you'd really want, what Java has is, you just keep a reference, you just keep track of how many pointers are to it, and then when all those pointers go away, automatically you say, oh, just release it. So what we can do is have a pointer, create a string object, but the string actually has a pointer to the real object, right? And that string with rotation now can actually keep track of a count how many pointers are pointing towards it. Oops. And No, somehow I lost it. So when you assign A equal to B, then what we do is we increase reference count to A, right? Cat has an reference count of 2, and when I assign A equals to C, now cat has a reference count of 3, but dog and mouse both have reference count 0 now. And so, right, we can now implement it so that our string representation will then free itself. Example of separating the implementation from the abstraction. And people actually implement it, the example, doing all this crazy C++ stuff to do that so we can keep track of. This is before they actually added some garbage collecting features to C++. So the reasons are, again, just for flexibility, right? You may want to choose which implementation at runtime. Or you may want to change implementation at runtime. In the Java AWT examples, that's when you choose the peers at runtime, right? And it's done for you. The programmer doesn't select, give me Linux button. And the Smalltalk example was example of one, you may want to change it during runtime.
So we saw the same example with abstract factor. So would those two things be a combination, or is it one?
Yeah, often you'll find them used together. And remember when we talked about the abstract factory, eventually asked the question, how do you keep them from cheating, right? When you ask the factory and then you downcast the object, well, the way you do that is use a bridge pattern. You don't have any of the actual underlying representation. Right, so the abstract factory is going to create the concrete implementation, but give it to you wrapped in the bridge, right? Because that's all it is, right? It's a button, right? We're done. And also the Java AWT example shows us, right, it's not necessarily the bridge just forwards all requests to, right, the implementation. When you look at the AWT code, they actually do a lot of work, right? And so they'll only use a few primitives from the actual implementation. Why? Because again, in that situation, we wanted, the way widgets work in different UI frameworks, different platforms are completely different, right? And how do you then, get some common behavior across, all platforms? Well, if certain behavior doesn't exist on a platform, well, we can implement it, right? Not in the implementation, but in the bridge part, so that when we call, we just use lower level features that everyone has. So yeah, we want to be able to subclass both of them. Right. There may be different types of windows, but we also want different types of implementations. And again, this is for the Java people. It doesn't make. I mean, it's like what? But in C++, it makes it's a big deal, right? Because as soon as you change almost anything, those changes the compiler complains about, so you have to recompile lots of code. Right, so now it can stop at the bridge. If I change the notation part, I don't have to worry about the uses of the bridge being have to be recompiled. Right. And we think it compiles being fast, but they can take a long time. You don't know what fun is until you got to compile. It takes an hour, right? And then you make a mistake. Yep. Yes. Yeah, get rid of different classes so that you can hide the yeah. So again, we get all these patterns which start the same, the structure is the same, right? And for me, the difference becomes, what problem are they trying to solve? What's their intent? Right, the bridge, right? We want to be able to vary that implementation without the outside world knowing about it. And it's something we do in advance, right? It's not like, oh, later on I decide. Whereas the adapter, it's like, well, I've got this thing over here which does what we want, but now it has to fit in this other context. And that context requires a different interface. So you end up with the same structure, right? Almost all the same problems, but it's just questions.
You emphasize the form of the pattern. It's almost more important. The problem is the general way that it's trying to solve it than the actual pattern.
Yeah, I would say so. Because, once you leave a class and you're not answering exam questions or trying to do assignments, right? You're writing code and you come across problems, right? Or issues. How can I resolve this? And it's like, okay, how do I solve this problem? And it's, particularly in a class, it's easy to get hung up on, well, is this a stat pattern or this pattern? And it's always nice to be able to say, oh, I'll use this pattern here so everyone knows what we're talking about, right? But a lot of them are just using indirection to make things more flexible.
It also would help
you. Yeah. Yeah, that's.
Because I'm always trying. If you don't know patterns, you think that the solution is unique. I call this thing, or what do I call it?
Standard, yeah.
So it does at least the next toolbox.
Terminology, right.
Yeah.
Yeah, terminology, yeah.
If I don't adapt, even if I don't use the adapter very close to the adapter pattern.
Right, yeah. Well, one more pattern, we'll go on to something non-pattern for a while, just to break up the monotony. The builder pattern, I'm going to build something slightly complex, but we want to basically break it into two pieces, so that using the same process, we can use the same instructions to create different things. What does that mean? Now that's, say we want to you can convert rich text format into different formats, right? So rich text format is this creative format that Microsoft created to export things from Word and Excel, right? But now it's like, oh, you may want convert it to Word, you want to convert it to making it a web page, create a PDF out of it. And so we can think of, okay, well, write a converter, you input rich text format, and then you output PDF. But of course, you're going to have to parse that rich text format, right? You have to understand the syntax and be able to parse it and figure out what's going on to know what this is. And then you have to convert that into PDF, right? And again, the PDF is another structure, right? It's another language that you create. That's all. I mean, that's all these things are, just the languages. And HTML is another language, right? And it has various constructs on it. So it'd be nice to be able to write my parser to understand rich text format independently from what it outputs. So I don't have to redo this every time I want to do PDF, I want to do HTML, I want to convert to text, right? And who knows what new format will come along, right? And so that's the goal of the builder is, okay, there's one piece that looks to say, oh, this is a paragraph. Okay, you go build a paragraph. Oh, here's a chapter. You build a chapter. Oh, here is a word. Build a word, right? Here's a first item in a list. Build the first item in a list, right? And then I can swap this guy out. Say, okay, have a PDF guy, right? And so when you say build a paragraph, okay, I'm going to build a PDF paragraph, whatever that means in PDF, right? Or give me a word. Okay, here's how I do a word in PDF. Now it's bold text. Okay, here's how I set bold text in PDF. And something different can do it for, say, tech, right? And so in the builder pattern, right, there's two pieces. One is a director, which is they're the ones that, okay, you guys, build a new paragraph, build a new sentence, build a new line, right? And the builder is the one that actually, okay, I'm going to here's how I build a PDF paragraph. Here's a PDF sentence, a PDF word, PDF font change, right? So typically the client says, yeah, let's create the director, give the director a concrete builder, and then here's what I want you to build. And the director goes, okay, do this, and tells the builder, here, do this, and then we're all done, right? The client gets the result from the builder, not the director. Why not ask the director for it? Yeah, it doesn't. It could be a PDF document, it could be a text document, it could be anything, right? Now the builder could pass it to the director, and the director could pass it to the client as a Java as an object, but then the client has to downcast it, right? So why not just right? And so yeah, we do something basically. I have something that parses and finds all the components, and then tells the builder, here's a character, here's a font change, here's a new paragraph, here's a new chapter. Now we can create different types of builders, right? Convert ASCII, convert HTML, whatever we want. Now we create the concrete builder, we give it to the director, and here's the text we want you to convert. So this pattern, you won't use as much as some of the other patterns, right? And the hard part is you have to understand, right? Say we actually wanted to do the RTF example, right? What do you have to do? You have to understand. Well, RTF is a language. You have to understand all the syntax, all the pieces of that language, right? There's paragraphs and sentences and words and different font changes, different sizes. All that sort of stuff you could do in Word, right? It has to be saved, saved as RTF. In a uniform way. So we have to understand that, and then we have to understand, okay, now what types of things will we want to do, right, to build out of that. It takes some thought to figure out what the build interface should be. But you have to understand all the pieces you may want to build. The XML example, right? So I'm sure everyone's familiar with XML. It's just HTML with general tags. And the problem is, right, we now use XML to store information in. We need to pull it out and do something with it, right? And you don't want every program to have to re-implement a XML parser. So there's a number of parsers out there, and a common one, the Java world, is called SAX, simple, where the A stands for, but X for XML. And they use the builder pattern. And so you have a XML reader object. That's the director. It knows how to read XML and all the various pieces of XML. And then you create what they call a concrete handler. And then you instantiate the XML reader. You say, here's my concrete handler. Here's my XML file. And when you're done, you get the result back, whatever that happens to be. And the concrete handler has all this interface, right? So there's characters, okay, end document, end element, right, which is XML. So you got the angle tag, so you get a new tag, the begin tag, end tag. And so there should be the start document, a start element. And then there's this ignorable white space, because again, there's white space you can add, right, between angle bracket, you can change that. But it may be that what you're building, and you want to know that there's extra space there for some reason, right? Most of the time you don't care, so your concrete handler don't do anything, but again, you have to look at all possible things that could come up in your instruction set. And then there's these various things which most people will care about or never thought about. There's prefix mapping, there's process instructions, entities that can be skipped. You have to sit down and figure out all the things that you're going to come across in XML. And build your build interface so it can accept any and all of them, because you never know in advance when you might come across a situation that needs that information, right? And that's one thing you have to be careful of, is that sometimes you're solving a problem that's right in front of you, right? So you do this, this, and this. But in the builder pattern, right, we're building it to be able to build different things from that instruction set, wherever it happens to be. And you don't know in advance. You may think, oh, who needs that ignorable white space? I mean, it's ignorable for the reason, right? But maybe you're typesetting a book, right? And that white space becomes important because you're going to do something with it.
So the builder pattern almost always uses data driven.
Yeah, you're building something, right?
Yeah, but you're building something data driven. Otherwise,
Yeah, it's pretty much always data driven.
and then if you didn't know the pattern, instead of converting one of these calls, just wrap it in, pass them.
That becomes harder because now you have to,
Yeah, harder. More potentially expensive.
yeah, but harder. You still have to tell so your builder thing has some other option, right? You say other, and then you give it this command to do something, but the director doesn't know what the inner workings of your builder, right? And so what sort of command can they give?
I'm saying each of those, in this case, they all have different parameters.
But if you're thinking that we don't know we don't know there's skipped entities, and later we come across a skipped entity, so we want to add that feature, right? You say you added a command, but now we need that command's going to act on the builder, right? And so now I need to know what method to call on the builder to actually.
On that example, the builder would grab it didn't care about the white space. But that's something. When you needed that, it's not the right tool for this.
Yeah, I think that would be hard to do. Because the builder, the director has to create the command, right? And if the director is good enough to know how to build a command for this particular situation, then why can't we build that into the builder's interface in the first place.
But if something new came along, use the interface.
You have builder interface number 2, right? Version 2. Which would be simpler than having, and then you have your director query the builder what version of the protocol you support. Then you probably want to break into smaller pieces. So yeah, this is basically simple API XML. Right, you create your handler, and then you pass it on, and you're done. Another example in Smalltalk, they have number builders. The most interesting one was a UI builder. And so they used that in 2 different places. You have a GUI builder, right? You drag a widget, put it there, and the standard GUI type of thing. And then the builder would actually build the instruction set. So you'd get, weird things like, initially you got they had their own little language they built, right? Eventually it went to XML, and then when you actually ran your application, right, the application would read this file, and the UI builder will then actually build the interface for you, right? The fairly common way of doing it now, in Android, when you create your interface, that stores XML, and then at runtime, it actually you read that file, and then it creates the interface object for you. But what happened, since they were using a builder pattern, they had the director and the concrete builder. When the web came out, someone said, well, we have this description of the interface, and we're using builder patterns, so we just write another builder. Instead of building Smalltalk objects, it'll build web pages. And so they wrote another builder that the director would use and pass this instruction set to it. Again, here's a button, here's a whatever, and the concrete builder output web pages. So literally, you could just take your current application and insert the concrete HTML builder, and all of a sudden your application turned into a web page system. No changes needed. Which is a very cool idea. Nice example of using the builder pattern, but there was one slight flaw in their system, and that is when you build applications, you assume the latency between doing something in the interface and your program reacting is basically 0, right? It's not true on the web. And it definitely was not true early on the web, right? Latency was a big problem. And so you take a program which is rid of the buttons and stuff, whatever, and you click on a button, things would happen, and you could throw one little switch, and it would turn into a client-server web program, right? But the problem, hit that button, it would then convert that into a web request and go back, right, to the server did a bunch of stuff, and then it'd come back, and it just didn't work, right? It was just, it might work now, but back then, the latency was too much. So it never really caught on. Now, you're going to run across lots of places where they talk about builders, but it's not the same as the builder pattern in a gang of four. It's a simplified builder. So let's say we have a person object that has a bunch of fields, right? And the problem is, we could create a constructor that has all these arguments. There's too many arguments, right? It's just too long. So instead, we'll build a person builder, and it basically contains all the information we need in the person object. Or it could, another way of doing it is we have a person object inside, and every time we change something, we modified it. But then we have all these build methods, which you give it one parameter, and it stores that parameter, and then returns itself. So you get a bunch of these methods. We don't want to do that. But building a person now, we can build a builder object, set the last name, first name, right? Call set that, do this, and then create person, which then returns the object. Various ways to improve on it, but you'll see this come, in Android to build notification. That's what you do, is you create a notification builder and say, add this feature, add this feature, this feature. Now give me the notification, and I'll call it. So say they call a builder, and just when you get too many parameters to pass in the constructor, we do one at a time, where you have a bunch of them, and you only have a few at a time. We can have defaults, and then you have this builder object to build it. You say, here's this value, no, give me the real thing. Off I go.
So it kind of reminds me of what we just looked at with the when.
Right. Yeah. And
then even a little bit of the Java strings.
Yeah. And it's it's also, functional programming, like I said, you have various constructs where you chain operations together, and the output of one is input the next, right? And Smalltalk actually has special syntax to do that for you. Basically, you're trying to send messages to the same object over and over again, right? Well, what happens is saying object A, A dot this, A dot this. That's all we're doing here, is making it easy to not have to say, builder, set last name, build it, right? We can chain them together, and Smalltalk has special syntax to make that easy without having to explicitly return the object over and over again in every method. So he has a common. And then we can ask, what's the difference between the strategy pattern and the builder, right? And what's similar? Well, the structure is similar, right? And the strategy, we have a different algorithm to perform some operation. But isn't that what the builder is doing, right? Concrete builder is a different algorithm.
Strategy.
Well, the builder is this algorithms do the same thing, and since you're building an object, right? But the name indicates that you're building an object, building something.
I mean, different builders are going to build totally different, whereas I think the different strategies would give you the exact same.
Not necessarily. I mean, layout managers give you a different layout. The screens are organized differently.
Versus HTML. You interface with it.
But in both cases, we're doing the algorithms, right? And we're giving different algorithms to. So what's the difference? Well, think about it for next time.